Gears. Let us consider two parallel shafts placed a small distance apart. Shaft 1 is the driver shaft and shaft 2 is the driven one. To transfer the power between the shaft, the two wheels are fixed on them and made to contact. The rotation of shaft 1 will make the shaft 2 rotate due to the friction between the contacting wheels. These wheels are called the friction disc. If we try to transmit more power, there will be slip between the friction disc due to lack of sufficient friction. Assuming no slip, we can write the relation between the speed of the disc. Let Vp is the common linear velocity at the point of contact of the disc. Vp is equal to omega 1 r1 is equal to omega 2 r2, which is equal to 2 pi n1 r1 by 60, which is equal to 2 pi n2 r2 by 60. We get the relation omega 1 by omega 2 is equal to n1 by n2, which is equal to r2 by r1, where r is the radius of the disc, omega is the angular velocity, n is the speed in rpm, suffix 1 refers to the disc 1, suffix 2 refers to disc 2. In order to eliminate the possible slip, we replace the disc with toothed wheels in such a manner that the speed of motion does not change. The teeth of both wheels mesh together to transmit motion and force. Thus, it converted into positive drive where there is no slip. These toothed wheels are called gears. We can say that a gear drive is equivalent to two friction discs in contact where no slip is allowed. When two gears of two different sizes are in contact, the smaller gear is called the pinion and the larger one is called the gear. When the two gears are in contact and they transmit motion, the angular velocity is inversely proportional to the size of the gear wheel. Since the pinion is smaller wheel, it will have a larger angular velocity compared to that of the gear, which is the bigger wheel. The power transmitted is a constant and does not change from the driver gear to the driven gear. It is given by the expression P is equal to 2 pi nt by 60. This means that speed into torque is a constant quantity for both driver and driven. So the pinion which has higher speed will have lower torque. The gear which has lower speed will have higher torque. When the pinion is a driver, the speed of output shaft carrying the gear is lower, but the torque output of the gear increases accordingly. When the gear is a driver, the speed of output shaft carrying the pinion is higher, but the torque output of the pinion decreases accordingly.